We think of black holes as these cosmic vacuum cleaners, just gobbling up entire stars. But have you ever really stopped to wonder, where does all that stuff actually go? I mean, what happens to all that mass? Well, that's the incredible mystery we're diving into today. It seems kind of impossible, right? I mean, Physics 101 tells us that mass can't just be, deleted from the universe. So if a black hole isn't just some cosmic trash can, what is it? And where on Earth is it hiding all that weight? All right, so to solve this puzzle, we first have to bust a huge myth. Seriously, most of us have a completely wrong picture in our heads of what a black hole even is. We tend to imagine a black hole as this super dense cosmic bowling ball, with all its mass just crushed into a tiny point in the center. But the reality? Oh, it's so much weirder. A black hole isn't an object in space. It's a place. It's a region where space-time itself has become so ridiculously warped that nothing, not even light, can get out. Think about it like this. When a gigantic star collapses and forms a black hole, the star itself effectively vanishes behind what we call the event horizon. But here's the mind-bending part. From way out in space, looking in, nothing really changes. The black hole has the exact same mass as the star that created it. The gravity is still there, pulling on everything around it, even though the thing that was creating it is gone. So, where is the mass? Well, the answer comes from Einstein, of course, and it completely flips our whole understanding of gravity on its head. It turns out mass isn't really a thing, it's a shape. See, Einstein's theory of general relativity tells us that space and time are actually woven together into a single four-dimensional fabric. And massive objects, like stars and planets, they don't just sit on this fabric. They bend and warp it. That curvature, that deep distortion in the shape of the universe, is what we feel as gravity. And this leads us to an absolutely stunning conclusion. Just like the slide says, mass is not in space. Mass is the curvature of space. Let that sink in for a second. The mass of the black hole isn't hiding inside it. The mass is the warp in spacetime. It's stored in the geometry of the universe itself. Wild, right? Okay, so the mass is the curvature. Got it. But what about the actual star that fell in? I mean, what happens to matter when it crosses that point of no return, the event horizon? Because once you cross that line, the rules change completely. To really get what happens to matter inside a black hole, we have to remember what what it actually is on a fundamental level. We like to think of particles as these tiny, solid little marbles, but in modern physics, they're not that at all. They're actually just ripples or excitations in these fundamental quantum fields that fill all of space. Everything you see, your hand, your screen, the stars, it's all just a complex dance of these fields held together by forces like electromagnetism. And inside a black hole, that dance is about to come to a very abrupt end. Inside a black hole, the tidal forces of gravity just become unstoppable. First, they totally overwhelm the bonds holding atoms together, ripping them apart. Then, they shred the atoms themselves into a soup of fundamental particles. And finally, in this ultimate act of cosmic destruction, even the quarks that make up protons and neutrons are ripped apart from each other. Matter as we know it is just completely unmade. And this is where our current tested physics completely breaks down. We're now venturing into the speculative but totally fascinating realm of what we might call the quantum core. General relativity on its own predicts something impossible at the center, a point of infinite density, a singularity. But in physics, the word infinity is basically a giant red flag. It's a sign that your theory has hit a wall and something else has to be going on. Most physicists believe that just before you get to that point, the universe's other rulebook, quantum mechanics, steps in and takes over. So what's really at the heart of a black hole? Well, the truth is, we don't know for sure, but the theories are mind-blowing. Is it a Planck star, a super dense ball made not of matter, but of space-time itself, held up by quantum pressure? Or is it something called quantum foam, a chaotic churning storm where our very ideas of space and time just cease to exist? This is the absolute frontier of physics, folks. So let's put all the pieces of this puzzle together. What have we actually learned? It all comes down to one incredible reality-bending idea. The mass is space-time. So here's the bottom line. That matter that falls in, yeah, it's gone. Completely, utterly unmade. But, and this is crucial, its energy is conserved. It doesn't just vanish. Instead, that energy gets woven directly into the black hole's gravity, adding to that intense curvature of spacetime. And that brings us right to our final, mind-bending answer. Where is a black hole's mass? It's not in a location. The mass is the location. It's stored in the very fabric of spacetime. The gravity we feel from the outside is the mass. It's one and the same. And all of this leaves us with one final tantalizing thought. Black holes are the ultimate cosmic laboratory, right? They're the one place in the universe where the two great pillars of modern physics, general relativity and quantum mechanics, are forced into the same room to confront each other. So could understanding exactly how they store mass, could that be the key that finally unlocks a unified theory of everything?